So here we're going to go over some nomenclature as well as some chair conformations. So in this first one of the nice things about when we see a position on a cycloalkane that has multiple substituents, that should usually get our attention that that's going to be a good place to start. Because if we start there, our first substituent is at 1 and our second substituent is also at 1. If we start anywhere else on the ring, our second substituent is going to be at a higher number. We should then number it in this direction. And so we have a 10 carbon ring. We're going to just go through and name our substituents, starting with 5-cyclopropyl. So anytime a cycloalkane is a substituent, it's just like if an alkane was a substituent. Propane as a substituent becomes propyl. Cyclopropane as a substituent becomes cyclopropyl. And a substituent like cyclopropyl gets alphabetized under C, not under P, because cyclo is not a numerical prefix. 3-isopropyl, 1,1-dimethyl, 9-pentyl, and since this is a 10 carbon ring, it'll be cyclodecane. Going to our other one, we have an almost identical type of situation in terms of our numbering. And so we have 6-bromo, 4-chloro, 5-isopropyl, 1,1-dimethyl, cyclononane. From here, we just have some chair conformations to work on. So starting with our first one, the first thing that we should notice is we have a tert-butyl group. Tert-butyl groups are always equatorial. This one is pointing up, so I'm going to make it equatorial up. And then I'm just going to walk around the ring. The next carbon just has hydrogens on it. The next carbon has an isopropyl down, then methyl up, and bromine up. Now, one of the most common errors that I see on exams is that students will decide, it helps to put all 12 substituents in. And so they'll do that, and then they'll put in the specific groups. And then they'll submit that answer. What's wrong with that answer? Well, what's wrong is that every one of these groups, such as here, 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 so on, look like they're methyl groups. And so if you're going to do it this way, which is fine, do make sure that you go through and label all of those other positions as hydrogens. All right, our next example is very similar. Again, we have a tert-butyl group, so that's going to determine where everything goes. Tert-butyl up, and I'm going to go around this way. The next carbon has a methyl down. Then the next carbon has an isopropyl down. The next carbon is this one, just has 2 hydrogens. Then we go to the next carbon, which has bromine up, methyl down, and then chlorine up. All right, here we have menthol. Our biggest group here is the isopropyl group. So that's pointing down. I want to get that into an equatorial position. Then we move to the next carbon, has an OH up. Next carbon, nothing. Then a methyl group up. And you can see we've clearly chosen the correct conformation, because in this case now all of our substituents are equatorial. And then these last two, they get more complicated because they've got more substituents, but the process is the same. Again, we're identifying by that tert-butyl group, making sure it's equatorial. This one's down, but then every other substituent just falls into place. So you're going to go this way. Up is that CH2I, down is the bromine. Next carbon has a propyl group pointing up. Then we have an ethyl down, isopropyl up, and then methyl up, chlorine down. Again, when we have a group as large as this tert-butyl group, in many ways that can make these problems easier because we set that group equatorial and everything else just kind of falls into position. Same thing in part F. Tert-butyl group up, ethyl up, bromine down. Now I'm going this way. Next carbon just hydrogens, then fluorine down, iodine up, chlorine up, methyl down, and isopropyl up.